Hi everybody, welcome to the lesson on hypothesis testing. I should actually say that this is the first of many lessons on hypothesis testing that we're going to do because hypothesis testing is really the primary tool of statisticians. This is how we answer the question, does the data support this thing I'm looking to support? Okay, does the data support my research question? So, big picture, how does this work? And that's what this lesson is going to be. We want to find evidence that a certain hypothesis is true. With hypothesis testing, we're going to assume that the thing we want to show is true is not true. And we're going to show that that is unlikely. Okay, and if this makes your head hurt, I think you're getting it. Okay? So again, we're going to assume that the thing we want to demonstrate is not true, and we're going to show that it not being true is unlikely. So yeah, this is a double negation. A double negative, I should say. So, in every hypothesis test, there are two hypotheses. There's the null hypothesis, which is labeled H with a subscript of 0. That's an O. That's a 0, not an O. So that's not O. That's H naught. And then there's the alternative hypothesis, which you'll sometimes see labeled HA. And sometimes you'll see labeled H1. But they mean exactly the same thing. And you always see them listed in this order. They'll list H0 first, and then HA or H1. And I'll go back and forth between these two, just like textbooks do. So when I said that we want to find evidence that a hypothesis is true, that's the alternative hypothesis. Okay, so we want to find evidence that the alternative hypothesis is true. So we're going to assume the opposite and show that that is unlikely. Okay? So this is always what we're doing. We want to prove the alternative hypothesis. So we assume H0 and try to see if H0 is unlikely. So next thing, we are always trying to support or show, demonstrate the alternative hypothesis. I purposely put this word prove in here, marked out, because remember we said before, in statistics you never say you're certain. This word prove sounds like it's done conclusively, that it's an open and shut case, it has been proven true. But that is not what we have going on in statistics. We never prove anything. We wish we could, but we can't. So support, show, demonstrate, find sufficient evidence for, but not prove. So we're looking to support the alternative hypothesis, but we start with this assumption of the null hypothesis unless and until we have enough evidence to show that the alternative hypothesis is true. So hypothesis testing was modeled after the criminal justice system in the United States. And you've probably watched enough cop shows or whatever to know that a person is innocent until proven guilty. So in a criminal trial, what they're trying to do is prove, even though we don't like the word prove, that the defendant is guilty. So this is our alternative hypothesis. Our null hypothesis is the opposite of that. That's the thing that we have to assume unless we find enough evidence to conclude that the person is guilty. And back to this up here, the way this works is we're going to assume the person is innocent, look at the evidence, and see, is that feasible based on the evidence? If it's not feasible that the person is innocent based on the evidence, then the person will be found guilty. If it is still reasonably possible that the person could be innocent, then they will acquit. And so that's exactly what's going on in our hypothesis testing. A little bit about language here, though. If in the criminal justice model, the defendant is found guilty, if they're convicted, then we say we reject H0, because we always start with this assumption of H0. So, if the defendant is found guilty, they say, no, this is not reasonable to conclude H0. There is sufficient evidence to conclude what this alternative hypothesis says. Okay, and we phrase that as reject H0. There is sufficient evidence to conclude that the person is guilty, or whatever this alternative hypothesis says. Okay? Now, if the defendant is found not guilty, the way we phrase that is not that we don't ever look for evidence of the null hypothesis. That's not the way this works. There is no burden of proof on the defendant. That's just the nature of it. If they're found not guilty, that just means we haven't found enough evidence to say that H0 is infeasible. Another way to say that is we fail to reject H0. Okay, that's the best way to say that. Fail to reject H0. And that tells us that there is not sufficient evidence to conclude that the person is guilty, or whatever other thing the alternative hypothesis says. Okay? So, for every hypothesis test, it's either going to be reject H0, there is sufficient evidence to conclude what the alternative hypothesis says, or fail to reject H0, there is not sufficient evidence to conclude what the alternative hypothesis says. Okay, now you're not going to literally say, whatever the alternative hypothesis says, but you're going to fill in with whatever you're trying to test for in that problem. Okay, there's no mixing and matching there. And there actually is no, people want to put the word because in there, but there's no because there. Hypothesis testing has really 6 major steps. And we're not going to focus on all of them today. Step 1 is going to be for later. Today we're just going to set up hypotheses. We're going to calculate the test statistic and p-value. The test statistic and p-value in the criminal justice analogy are the evidence. The rejection rule is essentially, I've watched too many court things on TV and you can tell this, I'm sure. But in different venues, different types of cases, they'll have different standards of evidence. So by preponderance of the evidence is one of them, where it's more likely than not. Some places it's beyond all reasonable doubt. That's in most criminal justice trials. I think in some juvenile cases it's beyond a shadow of a doubt. But basically that's our rejection rule. That's what our standard of evidence is. And then the conclusion, in the words of the problem, this is the verdict. Now, these other two, these are going to be later as well. But I wanted to put them out there so that you'll know these are key elements of hypothesis testing, just not for this test that we're doing today. Basically, checking assumptions is, a lot of hypothesis tests are based on the assumption of normality or other similar assumptions. So that's kind of done at the outset. And then these are some follow-up things that might happen after a hypothesis test. All right. So a key part of the logic of hypothesis testing is looking at the possible errors. So there's 4 combinations of things that could happen. We could reject H0 or fail to reject H0. And in reality, H0 could be true or H0 could be false. If H0 is actually true, we hope that we fail to reject H0. Okay, I'm going to write these out here because it helps me to be able to point at them. So H1, remember the thing we're trying to prove. And I've got this written here as H0 is nothing is there, and H1 is that something is there. Something is there like a relationship between 2 variables, or a difference between 2 means or something. So if H0 is true, we would hope that we would fail to reject H0. That's a correct conclusion. If H0 is false and H1 is true, we hope that we would reject H0. So reject H0 would be the correct conclusion if H0 is false. Okay, so this one and this one are correct. And by the way, this term significant, we'll talk about that more in a little bit, but rejecting H0 is just another way of saying the test is statistically significant. Okay, so there are two other kinds of errors. I'm going to plug in the criminal justice analogy here because I think it makes a lot of sense. So let's assume that H0 is false and H1 is true. So if the person is guilty, it would be an error to find them innocent. So if H0 is false, but we fail to reject H0, that's not good. This means we have acquitted a guilty person. Okay, that's bad. However, what's worse is if we convict an innocent person. And that's what's happening here. If H0 is true, that means that the person is innocent. But if the test is significant, that means you're rejecting H0, you're finding them guilty. So this is convicting a guilty person. Oh, I'm sorry, an innocent person. And that's worse. So this one is a type 1 error. This one's a type 2 error. But we designed this whole system to minimize the likelihood of this type 1 error. Okay? So the p-value, which we're going to be calculating in every hypothesis test, is the probability of making a type 1 error. So the p-value is the probability of rejecting H0 if H0 is true. And you find the probability based on the sampling distribution. And if that probability, if the probability of that kind of error is small, then we'll reject H0. Okay? And that's always going to be small. Okay, what I mean by that is we're always going to reject H0 for small p-values. Okay? The smaller the p-value, the stronger the evidence in favor of the alternative hypothesis. Okay? So again, back up to here. We're assuming the opposite. We're assuming H0 and trying to show it's unlikely. Unlikely would be a small p-value. Okay, so a small p-value means that H0 is likely false. All right, so that's it for this this first lesson. I'm going to stop the video there and then pick up again in a second video with the Z test.